Good morning, students.
Good morning, teacher.
How are you?
We are fine, thank you, and you?
I'm okay, thank you. Sit down, please. Now, okay, students, today we will learn about oxidation-reduction reactions. At the end of the lesson, you will be able to determine oxidation states and to balance redox reaction equations. Oxidation-reduction reactions are also known as redox reactions. You know, yes?
Yes.
Okay. Redox reaction describes all chemical reactions in which there is a net change in atomic charge. It's a class of reactions that include formation of a compound from its elements, all combustion reactions, reactions that generated electricity, and reactions that produce cellular energy. Okay, now today's terminology. Who wants to introduce with terminology? Dulati, please.
Terminology. The key idea is the net movement of electrons from one reactant to the other. Second, oxidation is the loss of electrons. Third, reduction is the gain of electrons. Fourth, oxidizing agent is the species doing the oxidizing. Fifth, reducing agent is the species doing the reducing.
Okay, thank you, Dulat. Sit down, please. Now let's remember for assigning oxidation states. Who wants to? Okay, you please.
The oxidation state of an individual atom is 0.
Nazım, thank you. Sit down, please. Who else? Birike, you please.
The oxidation state of fluorine is -1. -1 is compounds. In compounds.
Yerjan, you please.
Hydrogen generally has an oxidation state of +1 in compounds.
Okay, thank you. Who else? Alisher, you please.
Oxygen generally has an oxidation state of -2 compound.
Okay, thank you. Well done. Nordaulet.
In binary metal compounds, group 17 elements have an oxidation state of -1, group 16 elements of -2, and group 15 elements of -3.
Okay, well done. Thank you. Sit down, please. Now I want to ask the questions related to this topic. The first question, how to find the oxidation number for chromium in potassium chromate? Who wants to answer? You please, Ulpan. Come to the blackboard.
We are going to find chromium in K2CrO form, potassium chromate. We know that potassium is in the first group and we give +1. We don't know information about chromium. Oxygen always -2 with few exceptions. The 2 give us 2. Plus, we don't know chromium. -2 and the 4 give us -8. And the oxygen numbers must up to 0. 2 plus 6 -8 to 0. And we can say that chromium +6. Oxidation number of chromium +6.
Okay, sit down, please. Well done, Ulpan. Now, what else do you add to today's topic? Arujan, you please.
Oxidation involves an increase in oxidation number, while reduction involves a decrease in oxidation number. Usually the change in oxidation number is associated with a gain or loss of electrons, but there are some redox reactions that do not involve electron transfer.
Arujan, sit down, please. Well done, thank you. And who else? Okay, Tamilana, you please.
Oxidation involves the loss of electrons or hydrogen. Oxidation reactions gain of oxygen. Oxidation reactions increase in oxidation state. Reduction involves the loss of oxygen, oxidation or hydrogen. Oxidation reactions, loss of oxygen, oxidation reactions decrease in oxidation state.
Okay, thank you. Sit down, please. Okay, now students, we work in groups. I'll give you a piece of paper where further action is written. What should you do? The first group, read the text. Third group, yes? And second group. What should you do? Please read.
We must do an experiment.
Okay. Second group, you please.
We must write a Redox reactions.
Okay. And the third group?
We must make a conclusion.
Okay, sit down. I'll give you 4 minutes. Let's start, please. Students, time is up. Okay, first group, start please. Show your experiment.
I have taken magnesium sulfate and put
Firstly, I take potassium dichromate and to power into test tube. Then I take sulfuric acid and 2 power. And after I power peroxide.
Okay, students, well done. Good job. And second group, who wants to write the reactions? Okay, Berike and Asil, come to the blackboard and write your reactions.
Oxidation always occurs with the loss of electrons, and the reduction occurs with the gain of electrons.
Okay, thank you, Berike, Asil, sit down please. Well done. And the third group, come to the blackboard and give us your conclusion.
When the magnesium metal burns, it reacts with oxygen to form magnesium oxide.
At the end of reaction, we have taken chromium sulfate. Chromium sulfate has green color, and we have taken oxygen gas.
Well done, students. Good job. Thank you. Sit down, please. Now, students, I want to read interesting fact with Redox reactions. About Redox reactions. Redox reactions found their application many centuries ago. One of these examples is Greek fire. It was created by Byzantines in the 7th century. AD Greek fire could burn on water, and so it found its application in naval battles to destroy enemy ships. The composition of the mixture remains unknown, but some proposals were done. It said that Greek fire could contain petroleum, potassium nitrate, and possibly quicklime. Is it interesting? Yes. Okay, students, please write your opinion in your stickers. Okay, students, go to the blackboard and stick your stickers, please. Students, I like today's your job and your activity. Thanks. And home task. Please open your copybooks and books. Paragraph 16. Read the text and write your exercises. Exercises number 3 and 4. Your home task. If you have finished, okay, the lesson is over. Goodbye, students.
Goodbye, teacher.